The first bicycle lights were modified kerosene lamps fixed to the handlebars. The concept was truly trailblazing and made it possible to cycle at night. A century later, the technology has changed, but the concept remains the same. Bicycle lights are still showing us the way. These bicycle lights are battery-powered with energy-efficient LED lights. Mounted to handlebars or a helmet, they make it possible for a cyclist to see and be seen at night. A bicycle light starts with the design for the canister. In this case, it's for a handlebar-mounted trail light. Following that plan, computerized tools carve blocks of aluminum into a two-part mold for the bicycle light reflector. They secure the mold in an injection molding machine. Then they load white acrylic pellets into the machine's hopper. The machine grinds and melts the acrylic pellets into a thick liquid. Then it pushes the liquid into the crevices of the mold. The acrylic quickly solidifies into the shape of a reflector. An aluminum finish makes the acrylic shiny and reflective. Then it's over to a different injection molding machine. This one uses molten rubber to form 4 on-off buttons. A worker sets an LED-studded circuit board on a switch cradled in a fixture. She trims wires from the switch that protrudes through the board. She solders those wires to copper pads on the board, securing the switch and making an electrical connection. She removes the assembly from the fixture and threads the battery cord through the board. She attaches the board to a vented heatsink, which will draw heat away from the lights, allowing them to run more efficiently. She installs the reflector over the tiny LED lights. The reflector will focus the light forward, creating narrow beams. Another member of the team places a tray of reflector covers in a laser etcher. He closes the lid and activates the laser. It etches through tape that's been applied to the metal. The tape has a blackening agent on it. The laser transfers that blackening agent to the etched number, making it stand out. The number indicates the lumen power of the light. Lumen is a measure of the total amount of visible light emitted by a source. Back on the assembly line, a worker snaps the cover onto the bike light. Then she attaches an open guard to the heatsink to protect the cyclist from the heat generated by the LEDs. This bicycle light is ready to be put to the test. A technician turns it on and inserts it in a device called a lumen sphere. A computer analyzes the light and finds that it meets standards. Next, an employee builds a smaller bike light for a cyclist helmet. She inserts the LED assembly in the canister, then attaches the on-off button. She attaches the light to a circuit board with 3 LEDs. She tucks the circuit board into the housing and inserts a rechargeable lithium battery. She puts the assembly aside and attaches a red reflective panel to an aluminized reflector. She snaps the assembly into a clear plastic case, completing the rear light lens. She returns for the front helmet light and installs a reflector over the light. She screws on a glass cover that's framed by a metal bezel. She joins the rear lens and the LED assembly, encasing the electronics of this bike light. She switches on both lights to confirm that they're fully operational. These bicycle lights are ready to illuminate a rider's path, whether it's a shadowy mountain trail or a dark city street.